Hey everybody, this is Jason over at the Children's Museum of Houston, ASD Manager, here to talk to you some more about physics and some more about the wonderful world of making. Remember, what we're doing with this unit is we're trying to get the kids to make something, but to learn a little bit of physics as they make it. This time they're going to make a really cool thing. They're going to make a little sort of slingshot sort of idea thing. Of all the activities you're doing in this making unit, this is the only one where we give you a little bit of a guideline. And that's because to sort of cut and fold the inner craft tube is not always intuitive for a kid. To sort of punch a hole over here to put the pencil through is not always intuitive for a kid. So we give a little bit of instruction on this, but after that they can sort of make the slingshot their own. And that's what we're hoping they do. Remember, making is all about trying something. If it doesn't work out the way you want it to work out, trying something different. If that doesn't work out, trying something different. And keep on keeping on. Always keep on keeping on. Now, slingshots actually have a bit of physics that we talk about in another video when we talk about marble mazes. It's the same kind of physics. What we're really talking about when we talk about a slingshot is movement. So whenever you talk about movement, or causing something to stop moving, or causing something to project out, we're talking about our old friend Newton. Now, remember, Newton was this English scientist who was not only a physicist, he was also a mathematician. He was also a cat lover. That's always something that people don't know. One of the ideas he came up with the cat door. He invented the dog and cat door, which I think is kind of cool. So he was one of those guys who looked at the world, and when he saw something, he decided to improve upon it. And think about that. That's actually a really cool thing, this cat story. The reason why he came up with this cat door, he made one. It was the same idea as what we're doing. He didn't have any idea how it was going to go. He just made it because his cat kept pushing his door open, and it would disturb his studies or his research or what he was doing. So instead of like having the cat push it open and meow and all this stuff, he made a door for the cat. And that's the sort of same idea. This physicist was also a maker. He was also someone who saw something in that door that could be made. Same thing what your kids are doing. But he was also a great physicist, and he came up with this idea of the laws of motion. Now think about that for a moment. Laws of motion. It's pretty concrete then, right? These things are exactly the way it happens. It's very difficult for something to become law in physics. Einstein, who's arguably the greatest scientist of the last 150 years or so, actually doesn't have a single law. He has a theory of relativity. And you also got to remember, he did not win his Nobel Prize for the theory of relativity. But we'll talk about that some other time if you really, really, really want to get into physics. But the theory of relativity is becoming something closer and closer and closer to being a law, the more we learn and the more we explore our vast universe. So the laws of motion, as I said, we talk about them in another video, but it's always nice to have a refresher. And what we need to talk about are the three laws in order. So the first law is, once again, that law of inertia. Basically, something moving will remain in motion until acted upon by an outside force, and something at rest will stay at rest until acted upon by an outside force. Once your students can finish making their slingshot, that's going to be really easy to see. It's not moving. You can pick it up, it still stops moving at that point. But you have something that does move. You have like a little lever that does move. And when you move it back, you start the motion, but then you're stopping the motion is a sort of inertial force. But when you let it go, the inertial force is also when it hits the other craft tube. So you can really demonstrate this law of inertia very, very simple. Remember, there's a converse to the law of motion. Something that is at rest will remain at rest until acted upon by an outside force. Check out the Marble Mazes video and you'll see a pretty cool demonstration about inertia and also the third law. Now the second law, once again, it applies to all motion, but for the purposes of this making activity, it applies even less than the marble maze. It's the F equals ma, force equals the mass times the acceleration. Remember, mass never changes. Your mass is always the same no matter where you are. Your weight might change, but your mass does not. And remember, weight is specifically due to gravity, mass is not specifically due to gravity. That's why your weight changes. So when you're on the planet Earth, if you weigh 60 pounds, on the moon you weigh 10 pounds. It's 1/6 the amount of weight. So just keep those things in mind, that your mass is a constant thing. Again, you can gain a little bit of mass, you can lose a little bit of mass here and there, but for the most part, your mass will always remain the same. And definitely if you have a mass of 180 grams on the planet Earth, your mass will be 180 grams on the moon, or in the middle of space, or on the sun. So your mass will never change. Your weight will change, but your mass will not. Now, acceleration is the ability for something to move quicker. And force, obviously, is a push or a pull, or gravity, or these laws of motion, or anything that causes something to move about, or to stop moving about. All right, remember, unbalanced force, balanced forces. So basically the F equals ma equation is to make something accelerate, to make something move quicker, you times that by the mass of the object, and that's the amount of force you would have to use to make it do that. So if you are a mass of, say, 4 grams, and you have an acceleration of 4 miles per hour, or whatever it is, kilometers per hour, 4 times 4 is 16, so the amount of force, the amount of newtons you would have to use that are actually called newtons would be 16. Again, when you talk about the backside of your worksheet and your challenges, the math will have something to do with that, but until then, it wouldn't seem very logical or even very practical or even very observable to a child to really understand F equals ma considering a slingshot. But really important is the third law of motion. For every action, there's an equal and opposite reaction. And you can see that clearly when you pull this back. When the rubber band starts to vibrate, that's because the pencil hits the side of the craft tube. The opposite reaction is pushing back, causing the rubber band to vibrate slightly. Now you might not be able to see it clearly here, but it will vibrate very, very slightly. So you'll see that push back. So it's pushing one way and pushing back the other. These are laws of motion. Newton came up with them a couple hundred years ago, and we're still using them today, and they haven't changed. So, slingshots, basically they're used to project something. The classic slingshot we know of is the piece of wood with 2 sort of branches sticking out, and you tie something elastic to the end and you have a little cup and you can shoot little things out of it. But this one is good to shoot paper and whatnot. But that's the idea. You're going to shoot paper out of this one, and you're going to see how far it goes. And then you're going to try more paper, different size paper, crumbled up paper, less crumbled paper, and see if you can make it go further and further. And then that's when you can start to do the iterations of the slingshot. You can go ahead and see, like, okay, what if I added 2 craft tubes and 2 broken up craft tubes? Or what if I expanded the amount of pencils I used and taped 2 together? Or what if I use more rubber bands? Or whatever else you have in mind. Remember, always in a making project, we give you a certain amount of things so that kids can take home the simple slingshot. But if you have other things inside your supply closets, pull them out. Especially if you want to get rid of stuff. Pull it out and let the kids go to town with what they have there to see what they can improve upon their slingshot. One thing though, always, make sure every kid has a slingshot before you start to do the iterations, just in case you have more kids one day and you have to use all your supplies for everyone to make a slingshot. Then they can work together to improve their slingshots. If you have less kids, obviously you can use a lot more of the supplies. But things like the craft tubes and the rubber bands, we don't need that stuff back. These pencils we don't need back. We're going to make sure that all throughout the different sites that we go to, they all get this stuff. So you can use it all up as much as you want. And if you bring us 1 craft tube back and 1 pencil back, that's great. We're fine with that. If you bring us more, that's good too, but what I'm saying is because of this iterative nation of using these different supplies, go ahead and use as much as you want. All right, so have a good time making slingshots, and we're gonna do a couple more videos after this, and we want you to watch those too to get you some ideas about other making projects. This is Jason saying goodbye and have a nice day.